All right, here in this question, they ask you about a collision, but they give you kind of these picture visions, picture representations. The one thing to note is that right here, this velocity is twice as long as this velocity. They don't really clarify that, so I want to make sure you see that. So this guy is specifically twice as long as this guy. So it says, draw the final velocity of the pink car. I've got somebody that has 2m and twice the velocity, and then it bumps into somebody that has the same mass with half the velocity. After the collision, the yellow car has slowed down, and what happens to the pink car? So I just call them A and B. I write my equation for hit and bounce because that's what's happening. And for mass A, I use 2m. For VA initial, I use 2v, then 2m, and then just v. So this is how I'd represent the two momentums before. Afterwards, I have 2m and v, and then I have the pink car, which is 2m, and then some unknown v. And then I go through the math, the algebra. 4mv plus 2mv, I subtract this to the other side, so that's where I get these guys, leaving me with just this on the right-hand side. This becomes 4mv, because these two guys cancel out. I divide this 2m to the other side, leaving the VBF by itself. That gives me 2v. Okay, so what happens to this guy? His final velocity is doubled. He went from v to 2v. Then they ask, okay, if I were to double this velocity, but the final velocity stayed the same, what would then happen to this guy? Fine. You could work it out if you want to. I just solved the problem again. They said, if I double this velocity, what does that mean? That just means instead of 2v, it's 4v. Everything else stays the same, and I solve the problem. I do everything the same way. But when I double this guy, I also double the final velocity of b. So it was 2v, now it's 4v. So don't overthink it. Just rewrite your equation for hit and bounce. Instead of 2v, replace it with 4v, and then solve for the unknown VB final. Okay? There's the work. Now, lastly, they said, if the initial velocity of each cart remains the same, so exactly like you have it here, but the carts collide and stick together, how will the final velocity of cart B change compared to the original one? Okay? They're not really clear in asking that question. But all I do is instead of writing a hit and bounce equation, I write a hit and stick equation where the two masses are together at the end. So I have the original scenario, 2m, 2v, 2m, just v, and then afterwards they combine. So this gets added together, 4mv plus 2mv gives me 6mv. This is 4m, 2m plus 2m. I divide it to the other side. So I get 6mv over 4m. The m's cancel. I simplify this to 3/2, which is like 1.5 v. So what happened? Compared to A, he didn't speed up, he slowed down. He became 1.5 v instead of 2v. So compared to A, it would decrease.